If you go looking online for the asteroid called Apophis, you'll find a very specific nightmare waiting for you. It's a real rock, about 1,000 feet across, the size of a skyscraper, and it's named after the Egyptian god of chaos, the serpent that tried to swallow the sun and drag the world into darkness. It's due to pass Earth on Friday the 13th of April, 2029. Search that name, and you'll find video after video telling you that date is the day the sky finally falls. And here's what makes it hard to simply wave away. For a while, the scientists tracking Apophis were frightened of it too. When they first found it, it didn't behave the way a newly discovered asteroid is supposed to. The more carefully they measured it, the worse the odds got, until Apophis became, by the numbers, the single most dangerous object humanity had ever found. On the official scale astronomers use to rank these threats, it scored higher than anything before it or since. There was a real, calculated chance it would hit the Earth. And sitting behind that chance was a second one, stranger and harder to rule out, that even a clean miss in 2029 could quietly set up a direct hit a few years later. A quarter mile of rock, a fixed date, and a genuine question hanging over all of it. Is this the one? That's the question I actually want to answer, and not with the panic, but not with a lazy brush-off either. What the evidence really says, how the story turns, and the piece of it that even now isn't fully closed. To get there, you have to go back to where it all started, in the summer of 2004. Apophis was discovered on June 19, 2004, by 3 astronomers at Kitt Peak National Observatory in Arizona, Roy Tucker, David Tholen, and Fabrizio Bernardi. They caught it during routine survey work, the slow, unglamorous job of photographing the same patch of sky over and over and watching for the one faint dot that moves against the fixed stars. They found their dot. Then bad weather rolled in over the desert and they lost it for months, with only a rough arc of its path measured. That's how a lot of these stories start, and it's the part I never quite get over, not with an alarm going off, but with someone nearly missing the thing entirely. It's worth asking why anyone was looking in the first place. For most of the 20th century, killer asteroids were treated as science fiction, a Hollywood problem, not a real one. It was only in the decades right before Apophis that telescopes around the world began systematically sweeping the sky for the rocks that might one day have our name on them. Apophis was found because, by 2004, we had finally started to take the question seriously. It helps to know exactly what we're dealing with. Apophis is a lump of rock shaped a little like a peanut, somewhere between 1,000 and 1,500 feet across at its longest. That's not a planet killer, it's big enough to destroy a city. A rock that size coming down on land would flatten buildings for tens of miles, set off an earthquake, and throw enough pulverized ground into the upper air to darken the sky and cool the weather across a whole region for years. It'd be one of the worst days in a country's history, over in a few seconds. That difference, a city versus the whole planet, matters later, so keep it in mind. The people who named the rock clearly felt the weight of what they were looking at. They called it Apophis, after the Egyptian god of chaos. Then, at the end of 2004, the numbers did something they almost never do. When astronomers find a new asteroid and keep measuring it, the odds of an impact are supposed to shrink, and there's a clean reason for that. Early on, all you have is a short arc of the orbit, so the rock's future path is really a wide spray of possibilities, and if the Earth sits anywhere in that spray, there's a chance of a hit. Add more measurements, the spray narrows, and Earth almost always falls outside it. The risk drops to 0. With Apophis, the spray narrowed, and Earth stayed inside it, so the odds didn't fall. They rose. Through the last 2 weeks of December, the calculated chance of an impact in 2029 climbed night after night, and by December 27th, it hit 2.7%, about 1 in 37. Astronomers rank these threats on a scale from 0 to 10, a little like the Richter scale but for asteroids, and almost every object ever found sits at a flat, permanent 0. Apophis reached a 4. Nothing's been rated higher, before it or since. I find it genuinely hard to picture being in that room over the holidays, watching a number that's supposed to fall climb instead, toward a real chance of an impact on a date most of them would live to see. That 2029 impact got the headlines. But it wasn't what worried the experts most, and the thing that did takes a minute to explain properly, because it's the heart of the whole story. When Apophis passes Earth, our gravity bends its path, and how sharply it bends depends on exactly how close the rock comes. Comes slightly nearer or slightly farther. and it leaves on a different orbit. Now, there was one narrow band of space it could pass through in 2029, where Earth's pull would reshape its orbit by precisely the wrong amount, into a loop that carries it back around to the same spot at the same moment Earth is there again for a direct hit in 2036. Astronomers call that band a keyhole. Miss it, and Apophis sails past and stays harmless for a lifetime. Go through it, and the 2029 flyby quietly arms a collision 7 years later. So the real long-term danger was never the close pass by itself. It was whether the rock would thread that one small window on the way past, and it's a genuinely tiny target. The keyhole that could send Apophis back for a hit in 2036 is only about 2,000 feet across, roughly the length of 6 football fields laid end-to-end, floating in empty space. So the whole long-term question came down to something brutally precise. Would a quarter mile of rock in 2029 pass through a gap barely wider than the rock itself is long? To answer that, you have to know its orbit almost perfectly, and in 2004 we were nowhere close. Getting an orbit that exact takes 3 things, and for Apophis they arrived in order. The first was old photographs. Once astronomers knew exactly what they were hunting for, they went back through archived images of that patch of sky, taken months earlier for completely unrelated surveys, and found Apophis already sitting in them, before anyone had known it existed. I love that detail, honestly. Half of pinning down this rock's future was finding the places it had been hiding in plain sight all along. Those earlier positions stretched its measured path from a few months to years, and that alone sharpened the orbit enough to rule out the direct 2029 impact within weeks of the December scare. The second thing was patience. They tracked the rock on every approach, tightening the numbers each time it came around. The third was radar. When an asteroid comes close enough, you can bounce radio signals off it from a giant dish and time the echo, which measures its distance and speed far more precisely than any photograph can. So the danger came apart one piece at a time, over years. The 2029 impact fell away first, back in 2004. The 2036 keyhole was closed a couple of years later as the orbit tightened. A slim chance of an impact in 2068 hung on the longest of all, and it took until March 2021 to settle it, when Apophis made a distant pass, still nearly 11 million miles away, and NASA's giant Goldstone antenna in California, working with the Green Bank telescope in West Virginia, read its orbit by radar. That reading closed the book. Davide Farnocchia, of NASA's Center for Near-Earth Object Studies, said it plainly. A 2068 impact was no longer in the realm of possibility, and their calculations showed no impact risk for at least the next 100 years. For the first time since that week in 2004, Apophis came off the risk list entirely. So that's the reassurance, and every part of it is real. Apophis misses in 2029, and it can't come back to hurt us for at least a century. But that one sentence has 3 limits folded inside it, and they're the part almost every version of this story leaves out. Let me lay them out once, clearly, because together, they're the reason this isn't quite closed. The first limit is that 100-year figure itself. It's not a round number picked to sound reassuring. It's roughly the farthest ahead anyone can predict where an asteroid will be. Every time the rock passes a planet, that planet's gravity gives it a small tug. Those tugs pile up, and the tiny uncertainties in its position grow with each one, until, after about a century, the math simply can't tell you where it is anymore. As the astronomer David Jewett has put it, the longest you can predict with any real accuracy where a body like this will be is about 100 years. So no risk for 100 years isn't a promise about forever. It's the edge of what anyone can know, and Farnocchia's sentence was drawn right at that edge. The second limit is the one that genuinely unsettles me. Right now, we can't even watch it. Since 2021, Apophis has been sitting too close to the sun in our sky to observe, and it stays hidden that way until 2027. In 2024, the astronomer Paul Wiegert worked out why that gap actually matters. He showed it would take surprisingly little to shift Apophis's carefully measured path, even a collision with another asteroid as small as 10 feet across, a rock we'd have essentially no chance of seeing beforehand. The odds of that are tiny, far less than 1 in a million. But the stretch of years when a change like that would be hardest to catch is exactly the stretch we're in now, and we won't get a clear enough look to confirm nothing's moved it until 2027, only 2 years before the flyby. The third limit is the smallest, and to me the most interesting. Apophis is already drifting off its predicted path, very slowly, and we can measure it happening. Sunlight warms one side of the turning rock, and as it rotates, that warmed side radiates the heat back into space, and the faint push of that escaping warmth works like a tiny thruster that never switches off. It nudges the orbit by a few hundred feet a year. That sounds like nothing, and over a single year, it nearly is. Over decades, it becomes the single largest uncertainty in where Apophis will be when it matters. With all of that on the table, here's what actually happens next, and it's going to be a genuine spectacle. On April 13th, 2029, a Friday, Apophis will pass about 20,000 miles above the surface of the Earth. That's closer than our own communications satellites, the ring of them roughly 22,000 miles up that carry our television and our weather. A quarter mile of rock is going to slide in underneath our own machines. For a few hours, it won't be a smudge in a telescope. It'll be a point of light bright enough to see with the naked eye, moving visibly across the sky over Europe, Africa, and Western Asia. The closest an asteroid this size has come to Earth in all of recorded history. A huge share of the planet will be able to step outside and watch a known asteroid pass by with their own eyes, which is something no generation before us has ever gotten to do. And we already know that distance to within a few miles, years ahead of time. It'll be more than a light in the sky too. Passing that close, Earth's gravity will pull on Apophis hard enough to strain the rock itself, probably triggering small landslides across its surface, and maybe even changing the way it tumbles. That's exactly the kind of thing scientists want to watch from up close, so NASA's sending a spacecraft to meet it, a probe called OSIRIS-APEX. It's the same craft that already visited another asteroid and brought a sample of it home, now redirected to fly alongside Apophis through the encounter. The European Space Agency has proposed a second mission, called Ramses, to reach the rock before the flyby even begins. Everything they measure, the exact size and shape, how fast it spins, how well it holds together under that gravitational squeeze, is the sort of thing we'd need to know if we ever had to push one like it off course. I'll be honest, I find the whole prospect about equal parts wonderful and unnerving, and I don't think those two feelings cancel out. The entire 2029 pass is a free rehearsal, run on a rock we already know we'll miss. And rehearsal really is the right word, because Apophis isn't the asteroid we should fear most. The one that really matters is one we haven't found yet. Think back to why Apophis is invisible right now. It's lost in the sun's glare, and that problem isn't unique to it. Most of the asteroids we've ever discovered sit in the half of the sky facing away from the sun, where sunlight lights them up and they're relatively easy to catch. Anything approaching from the sun's own direction is washed out by that same glare, and to those rocks we're nearly blind. Astronomers get only a few thin minutes of usable twilight at dawn and dusk to hunt for them, fighting a bright sky the whole time. There are tens of thousands of asteroids out there big enough to destroy a city, and by most counts we've found well under half of them. The rest are still in the dark, and the very hardest to spot are the ones sitting between us and the sun. We've already seen, more than once, what that blind spot can do. The largest impact we know of in modern history came in 1908 over a remote stretch of Siberia called Tunguska. A rock maybe 200 feet across, still small compared to Apophis, exploded in the air and flattened around 800 square miles of forest. Something like 80 million trees knocked flat in an instant. It landed almost nowhere, over empty taiga, and even so it remains the benchmark for what a mid-sized rock can do. Then, much more recently, in February 2013, a far smaller rock, about 60 feet across, came in over Russia straight out of the sun. Nobody saw it coming because nobody could. It exploded roughly 20 miles above the city of Chelyabinsk, with something like 30 times the energy of the Hiroshima bomb, and the shock wave reached the ground a couple of minutes later and blew out the windows of thousands of buildings, injuring around 1,500 people, most of them standing at those windows because they'd come to watch the brilliant light in the sky. That one genuinely rattles me because it wasn't a near miss or a thought experiment. It happened to a real city full of people, out of the exact blind spot Apophis is hiding in right now. There's a real counterweight to all of this, and it deserves to be stated just as plainly. We've proven we can move an asteroid as long as we see it coming in time. In 2022, a NASA spacecraft called DART deliberately crashed into a small asteroid named Dimorphos and measurably shortened its orbit, the first time in history we'd ever shifted one on purpose. But that method only works with years of lead time, while the target's still far away and a small nudge has room to grow into a clean miss. Spot the same rock a few months before impact, and there may be nothing left to do but decide which coastline to move. The hard part was never moving an asteroid, it's finding it early enough for moving it to matter. A new space telescope, built specifically to hunt the ones hiding in the sun's glare, is expected to launch in the next few years, but it isn't flying yet, and until it is, that gap stays open. So here's where the whole thing leaves me. We caught Apophis, with 25 years to spare, and a long, patient chain of people turned a terrifying maybe into a date, a distance, and a light in the sky we'll get to stand under and watch. That's the system working exactly the way it's meant to. But it only worked because we saw this one coming from a very long way off. The rock that genuinely threatens a city someday probably won't introduce itself in 2004 and hand us a quarter century to do the arithmetic. It'll most likely come the way Chelyabinsk came, out of the one direction we can't watch, on an ordinary morning nobody thought to mark on a calendar. That's what I mean when I call Apophis a rehearsal. It's showing us the good version, the one with decades of warning, and reminding us, quietly, that the next one may not be so generous. So on the night of April 13th, 2029, if your sky is clear, go outside and find it. A steady point of light sliding across the stars. A quarter mile of rock passing under our own satellites and moving on into the dark. It's genuinely worth seeing. Just remember, while you're watching, that we get to stand there calmly and enjoy it for one reason only. This time, we knew it was coming. If you want more stories like this one, the real ones, about how thin the line actually is and the handful of people who spend their lives watching it, then subscribe. Finding them is what I do, and I'm nowhere near finished.